Welcome back to our Scala to Spark class, and today we will look at working with more complex types in our data frames. But first, let's fix a long-standing issue. Well, it's not really a big issue, but still kind of annoying to always have the warning, right? So we don't have the warning. At least I don't have the warning anymore. But unfortunately, the fix is not what I wanted to do. But the fix is actually turns out basically downgrading to a previous version of Java. So instead of using 11 or 17, right, I downgrade to 1.8, an older version, right? Again, that's what happens often, right? So it is officially supported, right? If you check your support list, right, what Java should you run, right? You should be running this officially, right? You should be running 8, 11, and 17, right? This was actually, right, so 3.3, right, runs as 8, 11, and technically also 17 should be supported at some point, but 8 and 11 is supported officially, right? So, it works fine on 11. We've been using it for now, right? But there is I checked with this Stack Overflow, right, and also so 11 actually gave some problems, right? So basically, again, this is Spark 3.2, but apparently this has not been fixed. So 3.3, this warning, I mean, it is pretty harmless warning, something to do with cache and reflection, but so you replace your SDK with 1.8. If you don't have it, you can add an SDK here, download JDK, right, whatever you want. If you want, so you can add whatever 18 or something, but officially only 1.8, which is 8, right? And 11 is supported, right? You can always download here, right? If you needed one, you could do JDK, and you could say where, right? Well, no, here you can say where you want it, right? And you could download it, right? So, so this is what you could do, right? You could add additional Java. Again, 1.8, it's been around forever. If you check our Java versions, right? You know, in Wikipedia, it's been around forever. Again, it's technically supported till 2030 again, so very old for a long time actually, right? Because, well, the whole world runs on it basically, right? So it is quite stable, right? So the 11 is actually not as long supported as long as 8. So 8 is going to be around forever. 17 even is not going to be around forever as 8, right? So it's super stable. But where's the downside to this? All right, you go down to older version of Java. For example, I needed to change a small tiny thing would not compile because we're using Java strings underneath. We didn't have is blank, it's actually is empty, right? So I can actually replace non-empty, right? So I have to replace view name is not. So if view name is non-empty, right, I use this to have string. This is a string, right? So if it's not empty, I want to create this view, right? So I had to replace this with not blank. So non-empty actually is a nice name, right? Actually better code, right? So we use that. And it should work now. So let's see. Now let's add everything. Let's test it. I tested with day 25, but let's do it with day 26, right? And then we can see. Right. So I will add it. New Scala class. Again, so sometimes you have to do a regression, meaning going back. So complex types, right? Complex types, right? And add. Of course, again, it doesn't. I mean, we still write the same Scala code, right? It's just that our engine or actual code is compiled to Java 8 code, not it's actually run by Java 8, right? So we compile it specifically for Java 8 JVM, Java Virtual Machine, not for 11, right? So a few small changes, right? Again, so let's try it, right? Let's see how it works. Let's see if it works out of the box, right? So we'll do again. We'll do the same thing, right? So something like this, right? Dealing, right, cancel. Dealing, of course, import. Nothing should change radically, but dealing with complex data types, right? Complex data types. So let's run it. See what happens. Oh, I'm sorry. I'm running the old 125. I didn't check. Okay, it's gonna run again, right? Notice, so it's running a different place. Java 1.8. So I recommend the Azul version, right? You should be able to download it, Java 1.8. Again, so if you don't want to rock the boat, right? The code should still run without changing this. Again, it's just that this warning is always it seems like okay, it's not affecting the performance, but again, you never know. Again, maybe there's something else, going on underneath, right? So stability, right? The price we pay for that is is that we have maybe few methods don't work anymore, right? But again, it should not affect, right? And let's see if it works. Session started. Okay, that's good. Will it work? Yeah, it looks like it worked. Did we have a new table? Yes, we have a df table. Everything worked, right? Okay, great. So everything works out of the box, and we can go on to complex data types. Again, so all I had to do is in project structure, go to 1.8, right? Again, if you don't have 1.8, you can download separately, right? You can find it where it is. So add the SDK, download JDK, basically on, right? You can add. It will find it, right? You can download immediately, right? There's also I have some extra other JDK versions actually, right? So where you have it, right? It's not so when you say add the SDK, you can say okay, JDK, right? And you need to tell it where it is, right? And if I download, right? If I even download, right? Say again. So download JDK, right? Okay, I choose. Okay, Oracle Open 18. I want maybe 1.8. Amazon Corretto is fine, or Azul, right? Azul Zulu commentary community. This is the longest supported version, the most stable. That is all the bug fixes and everything. There's also Ellipse, IBM version, right? They're all stable, extremely well used, right? I don't know what Bellsoft, I don't know that one, right? But again, they're all very stable, and they should be roughly the same, right? Again, used pretty much everywhere, right? By millions of machines. Okay, but again, so I have it, so I don't change it, right? I don't have it to change it, right? I only have this version here, right? So okay, and again, that's a big thing about, of course, compatibility wise, it's, you know, it will work, right? Okay, so that was a fix, kind of funny fix, right? But we don't have the warnings anymore. Okay, so now move on to complex types. Basically, why would we want complex types? They help us organize our data. Basically, again, they're not required, right? So there are three types: structures, arrays, and maps, right? So maybe slightly more, get you slightly more organized, right? So structures will be first one. It is basically like a data frame within data frame. And we can do something like this. We create it, right? We just select expression. So basically have a complex one, right? So if we do this, right, I'll do complex, right? Select expression, and so we have a new, so this expression, select expression, right? So here, right? ls complex, right? So create, and we'll create a view as well, right? So complex def will have a, so here let's see it here, right? So what's happening here? We don't have a structure, right? Okay, and now it works. Okay, so what happened, basically we combine description invoice under a basically subsection, right? So of course we do select, right? It will mean that I only have this this small tiny data frame, right? So that's one way of doing it, right? So now, of course, right, so we have data frame with a single column, right? So we can basically, right, so the only thing is we'll use a sub syntax, right? Maybe I will do this complex df, right, to show you this will work, of course, right? So yeah, I have to use get field. So it's like a nesting, right? Nesting operation, right? So basically, so we can do some select complex description, right, and to show, right? So let's take a look at what it looks like. So complex df show, right? 5, right? Maybe transcate false, I don't know. Right, let's see. So kind of like case class, not really, but this basically say class within, you know, columns within columns, basically, you can think of it, right? So you see how it is looks like here, right? Look at this complex, it's called complex, right? And so we have a comma, right, separate values, right? I mean, so but it is basically, you know, with a all the data information, of course, data types, everything is preserved, right? So it's basically just a nesting operation. So how do we see individual columns? Basically, we can use this, right? Either way, either column complex or use this select like this or that, right? So I'll show you both ways, right? So where's get field? So, and of course, we can use also SQL. That also will work, right? So, yeah. Right, so show, I need column, of course, right, column name. So either way will work, right, both next three methods approaches are equivalent. Right, so show, again, I'll show, you know, 3. So this will show you description, right, show 3, right, and of course, Spark SQL, right, and we can do this here, right? But not everything, but description, like this, right? And of course, I will show you show 3, right? Okay, so let's take a look if these three approaches will work. Of getting description column out of complex is the column, right, which holds 2 columns, right? So slightly more. Again, why would you want to make your life more difficult, right, by adding this extra nesting? Again, it will be for grouping purposes. Sometimes some libraries might need this might require this, but again, no need to actually do it without any good reason, right? But let's see if this actually is the same result. Yeah, so 1, 2, 3, exactly the same result. Okay, so again, so if you remember, if you need all columns, right, if you need all columns, you do complex set, right, complex set, select, and I do complex star, right? This will give you this show 3 for all columns in a complex selection. So for all columns in some complex struct. Let's do it again. I think this 108, I think it runs a little bit faster. I don't know, maybe just my impression, maybe I don't have enough, maybe right, this seems like Azul 1.8 seems slightly faster. Maybe there's some caching going on, right? It's maybe just impression, maybe not as fast, right? But speed up, right? And looks like it works fine. So you see, now it's back to normal, right? We do complex and so on. Okay, great. So we can work with complex and basically access these complex columns and without any extra problems. So let's move on to, let's see how we're doing this time. We're doing pretty good. Let's go to arrays, right? So we want to have, right, so idea is this, kind of crazy, but we want to take every single word in our description column, but actually not crazy enough to convert that into a row in our data frame, right? So the first task will be to use our friend split. We use it's Scala split, right, for strings, so something very similar, right? So we'll use a split, so we'll use delimiter, right? This is of course data engineering, basic data engineering task, right? So this is basic, right? So basically basic engineering, so basic data engineering task, right? And we want to, right, do this split. So we split selection. If we do it by ourselves, what will happen? Right? We use a splitter, will be white space. We have to define, we have to say, okay, if that's what we're gonna do. So let's take a look. What happens? Right? This is just regular. We need to, of course, use it. Not from here. Come on, more actions, import. Well, we'll need to find. We'll have to do it by hand. So it's in here, split, right? I'm pretty sure it exists. Yep, it exists. Oh, there you go. Okay, split. So description. So we split. Oh, let's do three rows, right? Truncate. Okay. So what will happen? So split. Let's read about it, right? Split string around matches of given pattern, right? Pattern. regex. So we use any regex you want, right? I can copy this. So split. I'll maybe copy this information for you. Come on, I can do this. How do I do this? Oh, here we go. Right. So, and we'll see. So we're selecting single column, but we'll have a. So what does it return? It returns a column, right? So what kind of column? It doesn't tell you, right? But it will be an array, right? Look at this, right? So split descriptions, there's some extra meta information, but look at this here. I should probably do truncate false, right? But it really did work, right? So it's split it into individual tokens, word tokens, right? So quite nice, right? So you have it, but of course, questions: how do you get these values out, right? But this is a good start. It's a good start, right? So quite powerful, right? You can do it also in SQL, right? If you want to make it, sure, let's do it in SQL as well. Same thing, right? SQL, same thing. So Spark, SQL, right? If you like, right? And it will be, of course, show 3 false. Right? Okay. I'll say my split. I'll call it as my split. Yeah, okay. I'll rename it. I don't like this name. So I want -1 refers maybe how many, right? So how will we get the values? Right. Okay. So my split. Oh, we see it. Okay. White hanging heart T held holder. So okay. So how would you, if you have this type of data frame, how would you get the values out? Right. Well, we use basically we'll need a array. Basically we can use the syntax, basically, right? We can use an array type syntax, so quite powerful, right? So we can use this as another column, right? So so this complex query, right, we'll need to make a name, right? And so of course something like array column, so we can actually see the values, right? So quite right. And then so we'll rename, because of course getting this name, that's why I renamed it as my split, right? Here it comes out to be quite ugly, right? This name, right? This column name, right? We want something a little bit nicer. So you go, also not Python, but so basically this little Python type syntax actually comes from Python, right? But using this is Python with using square brackets, but it's the same thing basically, right? So if you do this, right, in Scala, right, it's using this syntax, right? So basically you say, okay, you want the first column, which will be white, so on, right? And the thing is, can we do more, right? Can we do, let's say, expression, can we do comma? Can we do something else? Let's do, alright, call 1, right? Let's try this. Let me try this, see if this works. And so on, right? I don't have any more columns, right? Oh, yeah, because I selected this, only single one. Let's see what happens. Oops, I guess I didn't do it correctly. It's comma. I don't need to comma. How was it? Oh, I think it was select expression. Oh, it's multiplex. I think you have to multiply. I guess I didn't do it correctly. Okay, so yeah, sorry about that. I thought I had to do it. I guess it's like this, right? Yeah, I think so. Yeah. Okay. Control Z. Sorry about that. Control Z. And we go here, and we see now this should be okay. Yeah, Let's try it one more time. Yeah, looks nice, right? And of course, you can rename this column something else, right? Second, 1 second, first, a second, right? First, second, right? Okay, right? All right. So now, how about length? We might need something do about the length, right? So let's do about length. So we can use it to have the name the column, right? We want to see. We have split size, so we can use size of this column, right? So 5 and 3. Let's see how this would work in. Can we combine it, right? So this will work. Size, right? But let's do something a bit more. So we have this part here, right? Right. Let's do this, right? And I will do this array column, right? Can I do select, right? And I'll do this. So this is now at this point, right? Here we have a this column, right? I'll call it array length, right? rlen, right? And it is of course expression, right? So it will be size of array column, right? Okay, so now we need to import it, right? Import a prefix, yeah, but I'm just gonna do, okay, so function size, right? Array column, but it needs to be column. Okay, so call array. Okay, yeah, right. Okay, that looks okay. 1 2 3 4, one more, right? And then let's do show 5 truncate false, right? Okay. Let's see. So function size, of course, this means it imported list. Again, that's why, because size, of course, is extremely common name, right? So I use function size, right? But of course, what I do, I could do this, right? Of course, I could cut it off. It's red, but I could do it by hand. I could say size here, right? Size here, and I don't need this, right? Right. So that's fine, right? No problem, right? So let's see. So we are saying, so we know, so we add a new column using or only column from previous selection, right? We have, so what happens here? So we create a single column, right? Because select this column and select. Remember, this column creates a new column on top of existing. If you do select, you will be basically just getting some new columns, but you're not necessarily getting all the columns, right? Here you only get one, right? Just this one here. Okay, let's take a look. Should work quite nicely if I didn't make a big mistake, but who knows? It looks okay to me from here. And yes, okay, great. Look at this here. It works fine. So array column 1 2 3 4 5 5 3 5 6 5. Excellent, right? So we can analyze this already, right? Use it for some analysis if you want. And let's see if there's anything else we can do, right? So we can also check whether array contains, right? So again, I will be using this, right? So whether there is a void in this array contains method, right? We can check, right? We can create a new column, right? So we can also check, right? So I'll add the same one, right? So we can check was it void, right? So how would we do this? I'll create a new column, right? Here, right? This column, okay, void exists, right? And of course contain array contains, yeah, array contains, yeah, there is, thank you IntelliJ. There's also sort methods, and we need to pass column, right? Column, and it's array column, right? Okay, so this will be a boolean, right? This will be a boolean. So one more, 1 2 3 1 2 3. Do I have dot? What's the problem here? Column name, array contains. 1, 2, 1, 2. Why is it? What's the problem here? Let's try to compare. Maybe I don't see it here. Let's take a look. Array contains, right? What do you need? Column. Of course, right? Well, naturally, right? But I forgot to do. That's why Scala and IntelliJ work so well nicely together. Of course, I put value, right? Value. I want white, right? I'm checking for white, right? I forgot to add what I'm checking for, right? So let's do it again. Okay, you see how nice, right? True, false, false, true. So we can add more columns like this. I'm doing it so you can see how you can build up some completely new data engineering columns, right? And again, right. So now this is explode, right? This is also common in programming, right? You can explode. Yeah. So what happens? You split and then you explode, right? So what will happen? Right, you can explode a column, right? So what will happen here? It should be a huge number of white exploded. Let's see what happens with explode column arrays. It create one row. Creates one row with rest of values quadrupled per value in the array. So hello world, okay, other column, split hello world, okay, other column, hello other world, explode. Let's see if this actually works the way I think it works. Okay, let's try this. Let's run it again. Explode, I need of course import, that's natural. Right, so explode, new row for each element in the given array of map column. Right, so that's very interesting. So new row for each element. So this will be quite interesting, right? It should be explosion, right? Yes, it's an explosion. So quite interesting, right? So how else would you do this? So you explode in each row, so you create a new row. So this is quite interesting. So explosion. That's why I'll do something like a show like 20, right? Default like 25, right? False, right? So you'll see this better. So we split, right? But and then we explode, splitted, right? Exploded, right? And right. So and we select this column. This column is a description. So in description original. Well, I'll do it splitted also. I'll add splitted. So exploded. Splitted, right? I'll add one more. Okay, and one more stem. Okay, so invoice number, right? You can see this. Okay, let's see. So what will happen, right? It will take each. If you have 1, 2, 3, 4, 5, right? They will be. You have a row with this value, exploded, right? So this is common operation. Many. I think SQL also has this explode function somewhere, right? But so let's see if this works correctly, right? Because why? So you might say, okay, that's kind of crazy, you exploding it, right? But of course, since the thing is, rows are much easier to add than the columns, right? I mean, unless you're running Cassandra, which is a column database, right? You won't really want to look at this interesting thing, right? So you see how it works, right? Look at this, right? So I have a white hanging heart, that's the description, invoice number, right? So I exploded and I sort of added 5 rows. Instead of 1, I have 5 rows for this white hanging heart T-light holder, right? Of course, I still have access to the original data, right, up to us, right? But, so explode, I think it's also an SQL standard. SQL explode, right? Let's see if this is still, yeah. It's in Microsoft SQL, it's some other, I don't know if it's in MySQL, might not have it. I think it's, yeah, MySQL doesn't have it. I don't think SQLite has it. Let's see if SQLite, I don't think has it, right? So no, it's not. So it's in Spark. It's in some other Oracle, I think, has it. So it's in bigger database systems, but not in smaller ones, right? So yeah, but I hope you saw this idea how it works and used nicely. So for each entry here, we created an array, and then when we did explode, right, we did it. It created these multiple rows with each. Everything else is copied, right? So you can access anything, but you have a new entry, individual entry. So that's how you use it to explode. Quite nice, right? So quite interesting. So what else, right? So we see how it explodes. Okay, so now I think the last one is map. So you have key values, right? So similar how the array works. Of course, you just have keys. So you have key values. Then you can use it so to access it so let's see here. Then 1 second. 1 second here. Yeah. Okay. So we'll finish maps and then we can see on an exercise. Yeah, we're doing good. So maybe a little bit shorter. We're doing so much stuff. So you create maps, right? And we do it like this. So map function key value pairs, right, of columns. So map, right? So you're mapping description to, so it's a, so let's see what happens, how it will work. So you say description corresponds to column, right? It's pairs, right? So you pair key value. So you say these are going to be keys, these are going to be values, right? So it is, where would you use this? It's going to help with indexing, right? Complex map, right? So let's show it. Of course, you will need also description not null, right? So that's another thing. Right, I'll show 3 files, right? But also map I need to import it. Of course, again, another problem, right? It's there's so many other functions which use map, so I'll add it here, right? Map by hand. So let's run it. And also at the same time, I'll show you to save time. I'll show you this version, right? SQL, right? So oops, we need of course Scala Spark. Oh, sorry, Control Z, Spark SQL, right? Triple quotes, right? On now I can do it, right? Yeah, comment. Oh yeah, let's leave a comment. That's technically it should be okay, right? Comment. We'll see if this is a problem. Right, description. So notice we have to have a description is not null, right? And this automatically I guess picks up, but here it is needed to check, right? Because so we need notice how key can not be null. Apparently that's a problem. So okay, so of course I will do show 5 files. Let's see, it should be very similar. Let's run it. See if any problems. Worked fine. So you see the mapping. You see it's a mapping, not an array, but it's a mapping, right? Same types, right? So you say, okay, this corresponds to this in this value, right? So how could you do this, right? So key will get null. So you basically say, okay, so it's complex map. So it's very similar, right? How we would use by well, it's using kind of Python type of syntax, but it's very similar. It's basically key, right? You say, okay, you want to show this, right? Not dot, not array, but you use complex type, right? So, and also, of course, you can also explode, right? So I'll show you both, right? So this one, right? So this will, yeah, complex map. So you say select expression. So you only want this white metal lantern, right? So you say, okay, by complex map. So that's a key, white metal. So you will get. So that's the idea. You will get all of the metal lanterns, right? So let's say 5, right? and false, right? Right. Yeah, so it worked. Of course, in his case, you see that complex map, you only get null when there is no value, right? There's nothing corresponding to this value, right? You get all the rows, right? You also have use description right here, right? You see that it's only selected this particular value. So again, I think it's less useful, but again, you see null, you get null as well. So you can also get explosion, right? That's another thing you can do, or the last thing we can do. Right, so on JSON we'll do in the following sections. So you can explode, right? I'll show it to you, but it's maybe not something I particularly. I'll do explode like 12 false, right? Let's take a look. Okay, so explode, let's see how it works. Right, so while hanging letter, right, explodes, right, and it gets you, key, right, key and value, right, so explodes the value, right, for each of these, right, so for each, right, so basically you got it back, basically, you got the pairing back here, right, so maybe not useful. So okay, but let's look at what I would like you to see from you today, right? So what do we have? What is interesting? Description is the only thing we have really interesting here, right? We do, right? That's probably the most interesting one. Do we have any other columns which will be interesting? Well, let's take a look. So let's do to do, right? So what kind of file? Let me make you to do. Open exercise, right? Will be, let's look at our data. It's using 1.8, not 11 anymore. 1.8 here, right? From different directory, right? You can see. So CSV resources, we had retail data. Let's see what we have here. What's interesting? What interesting thing would we have? Retail data, right? So let's do something maybe with flight data, right? Do we have anything interesting here? Top destinations from 10 summary. Let's do maybe like 15 summary. Was this interesting? United States, not really interesting. No. We'll need that some more data for interesting something here. Maybe let's do again. I guess we'll stick with retail data, and we'll do maybe let's do. Let's do something like, I don't know, today, 12 years ago. Do we have anything like for that? Yeah, let's try this, right? So we have it. 11, no, we don't have 12, right? Do we have 12? No, we have 11, 12. So, 8, August 8, right? August, today's date. Do we have it? Yes, we have 4, right? So, 804, right? So, open up. So, open 4th of August CSV from 2011, right? Okay, so what do we extract? I would like to create a new data frame, right? With let's see if this will work actually, right? We would like to have a multiple, if we have descriptions, right? These only, yeah, this will be interesting text. Okay, yeah, good. Okay, with only with all the original columns plus array of of split description, right, plus length of said array, right, size, right, but filter by size of at least 3, right, then create, with select, right, add 3 more columns, for the first 3 words, in this data frame, right? So, and of course then show results, right? Show the top 10 results sorted by first word. Okay, something like that, right? So hopefully you'll see if these instructions are clear, right? Create new data frame plus array of a split description plus length of said array. So it will be 5. So again, 5 new columns, right? On with filtered rows, right? On sorted, and then top 10 results. Okay. So something like that, and of course false. So that should be a little bit more interesting than usual, I think. Okay, thank you.